Hello. So in this video we'll continue looking at isomerism now in alkenes. Alright, so look at isomerism in alkenes. Alkenes, we know that these have got, they are known as unsaturated. Why? Because they contain a double bond. They have a double bond. That means not all hydrogen atoms are used in bonding the carbon atoms. So not all, I'm just explaining the same unsaturated. Not all hydrogen atoms are used in bonding with the carbon atoms. For example, ethene, remember this, the general formula for alkenes is Cn. N is the number of carbon atoms, then H2N. For example, ethene has 2 carbon atoms. Now remember, the alkene group has got no methane. You can't find methane, so we don't have one carbon atomed alkene. You only have 2 going up. I hope that clears up. So the ethene has 2 carbon atoms. So it has 2 carbon atoms. This will give you 4. So the structure is this. This is the structure for ethene. If I say, let me give you the structure for propene. Propene has got 3 carbon atoms and 6 hydrogen atoms. So it has got 3. At some point, they're going to be a double bond. That's what you must know. Then it has got 6 hydrogen atoms. So come with me. Like that. Like that. Are they 6? Yes, there are 6. Now, why didn't I put a hydrogen atom here? Why? And why didn't I put another hydrogen atom here? Here's the question. We need to have 8 electrons for an atom to be stable. Carbon has 2 electrons here. 2 plus 2, which is 4. Plus 2, they are 8. This carbon has got 2, which is 4. 2 plus 2, which is 8. So you can say that if I put another hydrogen here, there will be 10, which is false according to electronic configuration. If I put for butene has 4 carbon atoms and 8 hydrogen atoms. So it has got this, that, and that. So I will do this, I will do that, I will do that. How many atoms am I remaining with? 5. How am I going to share them? I'm going to put 1 there, I'm going to put 1 there, I'm going to put 1 there, I'm going to put 1 there. Now where there's a double bond, you don't put. I've put 4, that means 1 is remaining. Does it make sense? It does. How? Because this carbon here has got 4 plus 4, 8. This one has got 4 plus 2, 8. Now when it comes to isomerism, like I said earlier, isomerism is just like you are drawing another form of the same hydrocarbon, but with a different arrangement of atoms, but having the same formula. Alright, so we have to draw another form of this hydrocarbon. For example, let me start from butene. So if I have to draw another isomer, another molecule with the same formula but different arrangement of atoms, I can draw one of them easy. I can have this double bond come there. Let me do this. One of them is this. One of them is this. Then a double bond there. You see? Then I can have something like this, just so that you will see. Remember, this must have that, this must have that, if I need to do that. So how many hydrogen atoms I've used 1, 2, 3, 4, 5. That means 3 are remaining. If I put that carbon which is remaining, remember there must be 4, and those 3 remaining hydrogen atoms have formed methane. Sorry, have formed a new isomer. But what's the name of this isomer? This is butane on top, but what is this new isomer called? You need to look at where is your double bond position, and you start from the lowest. So this is 1, 2. For alkenes with the double bond, you start from a carbon which is closer to the double bond, and this one is closer to the double bond. So 1, 2. So we call it 2. All right. So not 2 there. So start from the methyl group here is on which carbon? Carbon 3. Have 3. And the methyl group here, like I said earlier in my previous video, if you haven't watch it, 3 methyl group, in which alkene has this 3 carbon atoms. It's actually propene. So we are going to say 3 propene. Sorry, not 3 propene. Sorry. 2 propene. Why am I saying 2 propene? Because my double bond is on the second carbon. Does that make sense? I hope it does. What if I give you something like C5H10? This is pentene. Pent means 5. So if I draw the normal structure for pentene, I'm going to have this, then this. Then I'm going to have that, and that. I'm going to have that there. 4, 5, 6, 7, 8, 9, 10. Can I draw another isomer? Now let's draw isomers of this. One of the possible isomers that I can have these 4 hydrogen atoms, 3 like that, and if I want I can bring the other hydrogen and the other carbon with 3 hydrogen atoms, and I can have that, I can have that, keeping in mind this doesn't contain any hydrogen, and the last carbon only contains 2 hydrogens, as long as there's a double bond there. And what's the name of this? Because there's a methyl group on which carbon atom? 1, 2, 3. On 3 methyl, which alkene has 4 carbon atoms. And where is the double bond? The double bond is here. So that's 2 butane. Simple as that. Another possible isomer will be CC like this. Let me just draw it well. ABC, CC like this. You've seen? So I can have this one here. I can also have this one here. I can have this one there. This one there. That and that. Count how many hydrogen atoms are there. 3 plus 3. 6. 2 plus 2. 10. But what's the name of this? We have carbon 1, carbon 2, carbon 1, 3. So I have the first, I follow the order. The methyl group is the first, so I have 2. And another methyl group is where on the third carbon atom. There. So these are 2 methyl groups, so I'm going to say dimethyl. Then where is the carbon? Where is the double bond on the second carbon atom? And which alkene has 3 carbon atoms? That's actually propene. So this is 2 propene. And it's done. So I hope this works out for you. See you in the next video. Don't forget to subscribe. Ask where you can. I'll see you.